these plots can be really, really powerful displays of what your program is accomplishing. So what we start with are a series of load shape plots. So these top three panels on this graph, the red, the blue, and the green from left to right, are the average daily load shapes by season for the combination of measures that you input into your FLEXvalue scan. So if you have 10, 20, 30 measures or programs that are incorporated into a FLEXvalue scan, then this is the weighted average load shape of or it might be just the total load shape. I'm sorry, it's like the total average daily load shape corresponding to the summation of all of those rows that are in your input file. And then those translate respectively into those next three panels below, red, blue, green, that show you the avoided costs that are calculated each hour of the day during the summer, shoulder, and winter months. So you can see how your load shapes actually translate directly into avoided costs. In California, the summer peak hours are much, much more valuable on average than the rest of the year. So you can see that the spike in avoided costs relative to the shoulder and winter seasons especially is really pronounced in that summer avoided cost curve. And that's a reflection of the fact that a cost effectiveness calculation is a combination of the load shape and the avoided cost profile. So if you scroll down a bit, you also get a plot output that gives you all of the value stack of the avoided costs. So for folks who are familiar with the California avoided costs, there are 10 distinct value streams that are incorporated into the electric avoided costs. And right now, I should say all of these figures are devoted to the electric avoided costs. We may add some on the gas side eventually. The cost effectiveness calculation itself, like the TRC and the PAC, do include the gas component. So don't worry about that. These figures are mainly focused on the electric side, but you get the full value stack by hour of day for, again, the sum total of all of the measures or portfolios or whatever you included into the cost effectiveness calculation. And then if we keep going, you'll get just another breakout with some information of the avoided cost profile, the savings load shape, and the ultimate benefits profile. And then we provide some heat maps. So this heat map, the top one is showing you the GHG savings by month and hour. So you get a heat map across, month on the x-axis, hour of day on the y-axis, and you can see, for instance, that in this program, the greenhouse gases that are being saved are kind of concentrated into the sort of summer peak period when the grid is fairly dirty and when you're also saving quite a bit of energy. And given that there's an electrification measure in here, a heat pump, you actually see that there's some negative GHG corresponding to when that heat pump is added load to the grid. You can see that in red. And then you get the same kind of heat map representations of the avoided costs and the savings profile themselves. So savings on the left, avoided costs on the right. And then finally, we provide some cumulative sums to see how savings and TRC benefits accrue over the full 8760 hours of the year. So you can really see that the savings have a different profile than the TRC benefits do. And then the very last graph it shows you all of the components as they accrue over all 8760 hours of the year for the TRC benefits.